we talk about the what's it called? Oxidation and reduction, right? So as we said someone now called us to the attention of the definition of oxidation in terms of electron. I'm very sorry for the last class. So I did not even know that I won't be available. So very sorry for that. So now, so we now go back to the definition of oxidation number. I made a mistake on that. So, and I will need to correct myself. So oxidation in terms of electron gain and electron loss. Oxidation is the loss of electron. Is the what? Loss of electron. Oxidation is the loss of electron, while reduction is the gaining of electron. Please, can you hear me, please? What do I say about oxidation? I said oxidation is what? Oxidation is the loss of electron, while reduction is the gaining of electron. I'm trying to check this thing if it works well. Okay. It's not working for now. I don't know what's wrong with it. I don't know what's wrong with the pen. Okay, fine. So regarding the oxidation and reduction, so as I said, oxidation is the loss of electron, while reduction is the gaining of electron. That's just the small thing about that. Okay. The pen is not working. So now let's move on to the oxidation method. So we said we want to do balancing of redox reaction, right? We said redox reaction. When we say redox, it means oxidation and reduction. Is that also? So, and
Yes, sir.
I said we use two different methods of working out the redox reaction. We have half reaction method and oxidation number method. That's the two methods that we use in balancing redox reaction. So now in this, we have this equation. Let's check this equation. We have Zn, CuSO4, ZnSO4, and Cu. Who can tell me what has happened here? What kind of reaction is this? What kind of reaction is this? In types of reaction that we did, what kind of reaction is this? This. What kind of reaction is this? Let's talk, please. What kind of reaction is this? We don't know. ZnCu plus CuSO4. ZnSO4 plus Cu. Can someone tell us, please?
Reduction.
Reduction. In the types of reaction that we've done so far, types of reaction, and we have something like the Zn plus CuSO4 gives ZnSO4 plus Cu. What are the types of reaction we've done? What are the types of reaction we've done so far? Let's talk,
done
please.
combination reaction,
Combination reaction,
decomposition reaction,
decomposition reaction,
displacement reaction,
displacement reaction,
double decomposition,
double decomposition,
catalyst,
catalytic reaction, reversible reaction, and so on and so forth, right?
reaction. Yes,
Out
sir.
of that, what kind of reaction can we categorize the circled reaction that is here? Where can we categorize this as? Now, here we have
Displacement reaction.
displacement reaction. Thank you very much. So displacement reaction, it means that you went back to go and look at your book. You cannot identify it.
No, sir. I don't know this is what we are talking about.
Yes,
I
that's
don't
what I'm talking.
that's-
Yeah. So I said, with what we've done so far, what types of reaction can we categorize this as? That's what I asked. So that's the question I asked. Very clear. Okay, fine. So regarding that, so we have this kind of reaction. So they now said we should balance this reduction reaction to know actually what has happened there. The first thing is that what we need to understand in this case is to find which of the equation undergo oxidation, which of the other one undergone reduction. And what part of what we said when maybe like when copper or zinc, when it stand alone, the oxidation state of the zinc here is equals to 0. When it stand alone, it is what? 0. So we can now find when it's what? It's at when it reacts with another thing else. So we can easily find the oxidation number of zinc here. So here we have zinc here. Can you hear me, please?
Yes, sir.
Is there any background? Do we have any background here that is disturbing you?
No, sir.
No, sir.
Okay, fine. So regarding that, and we have zinc, we have CuSO4, we have ZnSO4, and we have Cu. Now, in this case, we can find the Zn here and here, and Cu here and here to check which one undergo oxidation and which one undergo reduction. Zn here is 0, right? But let us find the Zn here, the oxidation number of Zn here. So you can find it by saying ZnSO4 is equals to 0. Are we together? Very sorry, I don't know what's going on with this thing. So we have ZnSO4 is equals to 0. I don't know what's going on with my pen. So we have Zn SO4 equals to 0. How do we get the oxidation numbers of zinc here? Don't forget that SO4 in oxidation states, we have SO4 2 minus, right? Is that not so? Is that not so? Definitely Zn here. Before they can match together, we must have Zn2 plus. Is that not so? So
Yes, sir.
yes, Zn2 plus and SO4 2 minus. That's why we said we cross-link. When we cross-link, you are going to 2, we multiply this, 2, we multiply this, which is Zn2 and SO4 2, right? That's what we are going to have. Are we together? So we have 2 here. So these 2, we cancel these 2, which remain what? Zn SO4. That's what we have there. So Zn here in this case is plus 2. The oxidation numbers of Zn here is plus 2. That's why here we have Zn here to be equals to what? To be equals to 2. Now, definitely here we have Zn as 0. Here we have Zn as plus 2. Is that not so? Please, what has happened? Does it increase or decreases?
Increase.
Increases. That shows that oxidation state, that shows that oxidation has occurred here from 0 to what? To plus 2. Oxidation occur at what? At Zn. Are we together here? Now, Zn here, copper here is equals to 0 here because it stands alone. Here, it will be as that of the Zn. It is 2 plus 2 plus 2 here. Copper is plus 2 here at the reactor. Okay, what's your question, please?
Okay, thank you. Well done, sir. Well done, sir. Thank you. I'm sorry. The earlier you were asking about the type of reaction that occur between zinc and the copper tetrasulfate 6. Please, sir,
Yes.
I did not get the response. That what type of reaction is that, sir? Sorry.
One of our students said it is displacement reaction, and it is confirmed. Displacement. Are you with us, Abdulgani Abibat? So in our previous class, one of our previous classes that we did, so we did the types of reaction. So what are the types of reaction that we did? Then number 1, combination reaction. Number 2, decomposition reaction. Number 3, displacement reaction. Number 4, double decomposition reaction. Number 5, we did catalytic reaction. We also did reversible reaction as well, and so on and so forth. Now, when we see the displacement reaction, what it means, this is just the formula. When you have A plus BC, A plus BC, and it will now give you, it gives you AC plus B. This is just the simple equation for displacement reaction. Are you with me, Abdulgani Abiba?
Yes, sir.
So when we have something like this equation, we have A and we have BC, which this C will now collect the this B A here. We take C from B, which becomes AC, and B will be what? Will be left alone. That is why we call it displacement reaction. And why do we call it displacement reaction? Why is zinc displaces copper from SO4? Because in the electrochemical series, we've done it. That in electrochemical series, which is the electropositivity element, zinc is above what? Above copper. It has the capacity to what? To take any substituent from what? From copper. Are we together? So the power series of zinc is more than that of the what? Than that of the what? That of the copper. Are we together? That's why zinc can displace SO4 from copper. Have I explained myself? Habiba?
Yes, sir. Yes, sir. Thank you very much, sir.
You are highly welcome. So in this case, let's continue. For the CuSO4, it is still Cu2 plus SO4. Are we together? SO4 2 minus. So that's what we have in this case. So Cu2 plus and what? And SO4 2 minus. So in that case, in this case, copper here, it is +2. Why here it is what? 0. +2 to 0. Does it increases or decreases? From +2 to 0, it decreases. That shows that it has undergone the so-called reduction. Are we together? Yes, thank you very much. That's why zinc here undergo oxidation, while the so-called copper here undergo reduction reaction. Are we together? Are we together? That's fine. So at the reactant side here, copper is being splitted into Cu2 plus and SO4 2 minus. Likewise, zinc SO4. Likewise, we have here zinc plus and SO4 2 minus. So they are splitted. Are we together? So now this is still the same thing, but we split them into ions. That's why we have Zn solid, which is here. This CuSO4, we split it into Cu what? Cu2 plus what? SO4 2 minus. Are we together? So likewise, ZnSO4, we split it into what? Zn2 plus SO4 2 minus plus the copper here. Are we together? Don't forget that we still have the state here as what? As solid. Here, we still have it as solid here. Don't forget to put it there. We still have it as solid. So now, this Cu2 plus is in aqueous form. SO4 is in aqueous form as well. Are we together? So in that case, we have Zn solid plus Cu2 plus SO4 2 minus, which later gives Zn2 plus SO4 2 minus plus Cu solid. So that's what we have in this case. But in this case, what's the next step that we are going to do in this case? The next step is that we collect the like times, CLT. Likewise, we do in our mathematics, collect the like times. Are we together? So what are the like times here? The only like time here is SO4 2 minus and SO4 2 minus. Cu2 plus is quite different from Cu. Are we together? Are we together, please? So in this case, we are going to have Zn solid plus Cu2 plus SO4 2 minus. This plus SO4 2 minus is coming here, becomes minus SO4 2 minus, which gives Zn2 plus Cu. Are we together? Are we together? So this SO4, we cancel this, which later becomes what? We have Zn solid plus Cu2 plus, which gives Zn2 plus Cu. This is what we are going to have left. So this one is solid, this one is in aqueous form. So this is the equation that we are going to have here. So definitely that's what we have here. Cu2 plus Zn plus Cu2 plus and the likes and this. So when SO4 cancel SO4, what do we have? We have Cu2 plus Zn gives Cu plus Zn2 plus. Are we together? So there is nothing again. So this is how we balance the what? We balance the redox reaction. Are we together? Are we together? So is that okay? So do we need to write it or we already know it's like that? Very sorry, my pen is not writing. I don't know why. So I'll just need to do some things to it. So that's why there is delay on that. Very sorry about that. Can we proceed? Should we all we need to write?
We are writing.
Okay, fine. Are we done? Okay, fine. So that's how we go about the half reaction method. But now let's quickly move to the oxidation number method. This is where we are actually going. Oxidation number method. So how do we go about it? So we need to follow the below procedure. You need to follow the below procedure. Number one. So the following procedure were adopted in oxidation number method. We can write it there down. Number one, we identify the element. Number one, what we need to do. Let me just summarize it for you. The first step we need to do is that we identify whose elements undergo oxidation and whose elements undergo what? Reduction as well. What are those elements? So we quickly identify that. That's number one. Number two is that after we've identified that this element undergo oxidation, while the other one undergo reduction, the second thing is that we need to balance each half cell separately. The oxidation one, we separate it, while the reduction one, we separate it as well. Are we together? Are we together? That's the second principle. So now, the third one that we need to, you might not follow this. Are we together? The third one is that all atoms of oxygen, all atoms of oxygen in that equation must be balanced with water molecules. Are we together? So definitely if we have oxygen, maybe if we have oxygen here, maybe we have 3 mole of oxygen here, 3 mole of oxygen gas here. Then we have 3 mole of oxygen. Okay, don't let me just put, maybe we have SO4. Okay, let me just put it this way. If you have 3 mole of oxygen gas, are we together here? So we can count the numbers of oxygen here. How many numbers of oxygen do we have here? We have 6, right? Are we together? This is the reactant side. If we have these 3 mole of oxygen gas, which is 6 oxygen, 6 numbers of oxygen here, we balance it with 6 molecules of water. We balance it with what? 6 molecules of what? Of water. Are we together? So it means that oxygen has been balanced here. Are we together? It means what? Oxygen has been balanced here. We have 6 numbers of oxygen here. We also have 6 numbers of oxygen here. Are we together? This hydrogen at this side, you know, we have hydrogen atoms, which is 6 molecules of hydrogen atoms. How many numbers of hydrogen do we have here altogether?
12.
12. So now in this case, when you have 6 atoms of oxygen here, and you want to, which is 6 numbers of hydrogen here, 6 numbers of hydrogen here. Now, at the other side here, you balance it with hydrogen ion. You balance it with what? Hydrogen ion. In this case, we have 12. It will now be, this one will now be 3 oxygen plus 12 hydrogen ion. Are we together? Are we together? Are we on the same page? So when you now check this, you will see that everything has been balanced. We have 6 here, 6 oxygen here, which has been balanced here with 3, 2, which is 6. We have 12 hydrogen here. We also have 12 hydrogen here. We balance it atomically. We balance it what? Atomically. That's actually what we are saying here. So what we need to say is that, okay, we balance the water molecules from one side. We balance what? Oxygen atoms from one side with what? With water molecule at the other side. Are we together? That's why they said here, add appropriate numbers of hydrogen, add appropriate numbers of water molecules to the side that is what? Deficient in oxygen atoms. Are we together? Definitely the oxygen will be balanced with what? With water molecules at the other side. Why hydrogen atoms at the other side will be balanced with what? With hydrogen ion at the what? At the other side. So that's why they said add H plus, which is hydrogen ion, to balance what? Hydrogen what? Hydrogen atom. So definitely hydrogen ion will be used to balance what? Hydrogen atoms. Why water molecule will be used to balance what? To balance oxygen atom. Are we together? Are we together? So that shows that we get it right. So the last one is that, the next one is that add enough electron to the side. So what they're actually saying is that we should balance the electron at the side that is what? That is more positively charged. That is more what? Positively charged. So, or less negative charges. So we are going to what? We are going to understand that as we are moving. So The last one is that multiply the half reaction by appropriate coefficient to balance the electron loss or gain. Electron loss or what? Or gain. Let me just quickly use this to do the example. This equation. Let's go with the equation. We have MnO4 minus plus SO2 which gives Mn2 plus SO42 minus. The first thing is that we need to first check which of the elements or compound undergo both oxidation and reduction. Are we together? In this case, we have Mn here, and we also have Mn here. That shows that we need to check for the Mn that is in this equation. Here, it shows that Mn is +2 without finding anything. Is that okay? Mn is +2, but we need to find Mn here. What is a ion of Mn here? So using the oxidation, how to find oxidation that we do use, how we find oxidation number using oxidation number process. So we have what? MnO4 minus, O4 minus. So we want to check the oxidation numbers of Mn here in this case. So Mn plus how many atoms of oxygen do we have here? 4 atoms of oxygen, right? Which is equals to, don't forget that we have negative here. All equals to, this negative means all of these, they are equals to -1. Are we together? So in this case, we have Mn plus, who can tell me what is the oxidation numbers of oxygen? Oxidation numbers of oxygen.
-2.
-2. We have -2, which is equals to -1. So 4 times -2, that's -8. We have Mn -8. Do you know how we get -8? Equals to -1. This -8 will come here and becomes what? +8. It will now be Mn is equals to -1 plus 8. What is -1 plus 8? What is Mn in that case?
7.
Is it 7 or +7?
-7.
+7.
Who said
+7.
-7?
Plus
+7.
7.
So now in this case, Mn in this case is +7 here at the reactant side, and it is +2 at the product side. What has happened here? Does it increases or decreases?
Decreases.
Decreases. What kind of reaction? has occurred here now?
Oxidation.
Oxidation,
Reduction reaction.
reduction reaction. Reduction has occurred because it is from +7 to +2. That means that it reduces. So its reduction reaction has occurred here. So from Mn here to Mn here, we have reduction. Are we together? So do we need to write this down? Well, let's quickly write it down. That is how we get our reduction reaction for Mn. If this one is, if MnO4 to Mn2 plus is reduction, what will be SO2 to SO4 to minus? Hello, are we together? That shows that the other one will be what? The other one,
Oxidation.
oxidation. Now we are going to check if truly it is oxidation. Are we done with what we are writing? Are we
Yes,
done?
sir.
Okay, fine. So now the second one is that we have SO2. So we want to determine the oxidation numbers of sulfur here. So because we can easily get the oxidation numbers of oxygen, we know that the oxidation numbers of oxygen is -2, right? So we have sulfur plus 2 oxygen, which gives what? Do we have any ion here? No, so far we did not have any ion. It will equals to what? It will equals to 0. Now, what's the oxygen numbers of oxygen? -2, that's S plus 2 into bracket -2, which is equals to what? Which is equals to 0. Are we together? 2 times -2, that's -4, right? -4 times plus, that's S minus 4, right? S minus 4 equals to 0. What will now be our sulfur in this case? Our sulfur here is what? +4. So our sulfur here is +4. In this case, we have 4 +4. So now let's now check the sulfur here as well. I think we need to be fast with that. So in this case, we have SO4 2 minus. SO4 2 minus. That's what we have at the product side, SO4 2 minus. If you want to do it here, we know that it will be sulfur plus 4 atoms of oxygen, right? 4 oxygen here, which is equals to, don't forget that we have, what's the ion that we have here? -2, right? Is that also -2?
Yes, sir.
Yes, sir.
We have equals to -2. So S plus 4 into bracket minus 2 is equals to minus 2. Are we together?
Yes, sir.
Yes, sir.
Plus 4 times minus 2. Adebimpe,
Minus
please mute your mic. What's it? Adebimpe, please mute your mic, please. Fine. We have so 4 minus 8, which is equals to what? Minus 2, right?
Yes.
So when minus 8 comes here and becomes what? It becomes what? It becomes plus 8. That's S equals to
10.
minus 2
minus 2 plus 8
plus 8. And what will be our answer? What will be our answer for check for?
plus 6
Plus 6.
Minus 6.
Who
plus
said
6
minus?
That is
Is
plus
minus
6.
2 plus 8 is minus 6. It is plus 6. We have plus 4 here. And here we have it as plus 6. Does it increases or decreases?
Increases.
Increases. That shows that oxidation has occurred between SO2 and what? And SO4 minus. Are we together? Yeah,
Yes,
let's
sir.
quickly put it down, please. Let's quickly put it down. Are we done with it? So definitely fine. So can we proceed? So we now split it into half equation. We will need to identify which one undergo oxidation, which one undergo reduction. The oxidation one, we have SO2, which gives what? It gives what? SO42 minus. That's oxidation. This is, you just write it there, oxidation. Oxidation. While the second one, which is MnO4 minus 2 Mn2 plus. This is what? This is reduction. Are we together? This is equation. This one is what? Equation 2. Splitted it now. Don't forget the rules. Have oxygen. We have oxygen here. We have 2 here. we have 4 here. Shows that to balance this one, how many oxygen do we need to make it complete? To balance this oxygen here, how many oxygen do we need? We have 2 oxygen here, we have 4 here. And we need to balance this oxygen as well. How many atoms? We need 2. And whenever we want to balance oxygen, we are going to, in the procedure, they said we are going to balance the oxygen with what? Where we have deficient oxygen, we are going to balance it with what?
Water.
Water molecules. So definitely, so far it remains 2 oxygen to make this one to complete. Definitely, we are going to balance with what? 2 molecules of water. 2 molecules of what? Of water. Are we together? Are we together?
Yes,
So,
Yes, sir.
so it seems we understand this. Now, if you now check, we have here 1 sulfur here. We have 2 oxygen with 2, make it 4, right? And we have 4 oxygen as well. But at this side, we have hydrogen, right? But we did not have it at this side. Definitely, we need to balance the hydrogen atoms. How many hydrogen atoms do we have here?
4.
4. And whenever we want to balance hydrogen atoms, what do we use to balance it? From the procedure. We balance it with what?
Oxygen.
No, whenever I want to balance hydrogen atoms, this is it. Hydrogen atoms is balanced with what? With hydrogen ion.
Hydrogen.
So now we have 4. Okay, thank you. So we have 4 hydrogen atom here. The numbers of hydrogen here is 4. So we need to balance it with what? With 4 as well. 4 hydrogen ion. Are we together?
Yes, sir.
We balance it based on the number. Based on number. All together here, we have 4 hydrogen. We need to balance it with 4 hydrogen. Here we have 4, but here we have 2. We have 2 deficient. Are we together? That's why we balance it with 2 molecules of water. So that the oxygen will be what? Will be 2 together. Are we together? That shows that this has balanced. Let's check either if the first equation has been balanced atomically. Let's check. How many sulfur do we have here?
1.
You have
1. How
1.
many sulfur do we have here?
1.
1 as well, right?
Yes.
Let's go for the oxygen.
Mm.
We have 2 here. We also have 2 here. Make it what? 4.
4.
How many oxygen do we have in total here?
4.
4. Hydrogen. We have
Hydrogen.
4 hydrogen as well. We also have what? 4 hydrogen.
Hydrogen.
So that this has been balanced
Equation.
atomically balanced. Atomically. We balance it atomically. This is atomically. We balance it atomically. Let's go for the second one, second equation. Don't forget that this is oxidation, while this is reduction, right? Thank you
Yes,
very,
sir.
very much. Now, Mn here, we have Mn, 1 Mn. We also have 1 Mn. Fine. We have, how many oxygen do we have here?
4.
4. Do we have any oxygen here?
Oh,
No.
No. Now, how are we going to go about this?
water.
We
We
check
balance
our
it.
law.
We balance it with what?
Water.
Water. And how many molecules of water are we going to use to balance it?
4.
4. Thank you very much. Definitely, we add 4 molecules of water. Now, hydrogen, we've added hydrogen to it, right?
Yes,
Yes,
sir.
sir.
How are we going to balance the hydrogen?
Hydrogen
With
ion.
hydrogen.
Hydrogen ion. How many atoms?
2.
How many atoms of hydrogen ion are together?
2.
16.
Okay.
Eight.
But I 2 years.
Eight.
8.
8.
We have 8
Eight
hydrogen
plus
ion.
8 plus.
Are we together?
Yes, sir.
Yes, sir.
Anything to balance?
No,
No.
our Mn.
What
No.
happened to it, sir?
ML is already balanced.
Already balanced. Thank you. So definitely we balance it atomically. And the second step, the third step is that we balance ionically. We balance what?
Ironically.
Ironically.
So let's write this down, please. It is because of the pen that is not working. That's why we're having a issue here now. Can we proceed, please?
Yes, sir.
Okay, after that, we need to balance. We balance what? Ionically. So, for the first equation, we have SO2 plus 2H2O which gives SO4 2 minus plus 4 hydrogen ion. That's what we have, right? So let's now
Yes, sir.
balance. Let's balance it. So there is no ion. We don't have ion here, right?
Yes, sir.
We have no ion here, 0, right? We have ion here.
No.
Yes, sir.
Yes.
What do we have here? We have -2.
-2.
What do we have here? The ion here is this 4 makes this ion to be equals to +4. Are we together? If it is
Yes, sir.
8 plus we have here, it means the ion here is also +8. Are we together?
Yes, sir.
Yes, sir.
If we have 2SO4 MnO4 2 minus here. These two will multiply this ion and becomes what? -4. Are we together? That's actually what happened. So in this case, we have -4 plus 2, -2 plus 4, and we have it 0 here. 0 plus 0 will give you what? At the reactant side, we have 0. At the product side here, we have what? +2 -2 plus +4. -2
+2.
plus +4. Someone said it is +2. Correct, right?
Oh,
+2.
yes.
Are we together?
Yes, sir.
Yes, sir.
Are the ion number of both reactant and the product the same?
Oh,
At this side we have 0, at this side we have +2. They are not the same, right?
Yes,
Yes,
sir.
sir.
yes, sir.
Now, in this case, the ion what electron can now enter. Electron will now what? Enter.
Enter.
Okay. Are we together? We will
Yes,
now
sir.
add electron in this case. How do we now add electron? When you add electron is minus, right? It is E minus. It means when electron is added, it will reduce the equation, the ions of the equation, right? Because it is minus. When minus is added to an equation that has plus, it's what? It will reduce it. And we need to let this ion, since this one is 0, this one is +2. We need both of them to what? To be equal,
The same.
Equal.
to be the same. Are we together? So this
Yes,
one
sir.
is +2,
Yes, sir.
this one is 0. But if you want to add electron, we add electron to the side that has high positive charge. That has what? High positive charge.
High.
That's that here we have +2, right? What
sir.
electron are we going to add to this +2 to make it 0? How many electrons?
Two.
-2.
2. We add 2 electrons. Definitely, in this case, if you add to this side, if you add 2 minus, 2E minus, let me rewrite it so that it will be clear. Sorry. SO4 2 minus plus 4H plus we now said we add 2 electrons to it, right?
Yes, sir.
We add 2 electrons. When you add 2 electrons to it, let's check if all this is equals to 0. This one is -2, right? The ion for this is -2. The ion for this is +4, right?
Yes, sir.
Yes, sir.
What will be the ion for this?
-2.
Have you -2?
-2. -2. That's -2 plus 4 plus 2 plus 2 minus 2. What are we going to get?
0.
0.
Yeah.
That shows that we balance this equation ionically. We balance it what? Ionically. Let's put it down. So, okay, without wasting much of our time, let's do something for this one as well so that you can write it together. This is MnO4 minus plus H plus, right? We
Yes,
have MnO4 minus plus 8H plus, which gives us Mn2 plus 4H2O. Are we together?
Yes, sir.
So let's check it. What's the ion for this? What is the ion? What ion do we have here? -1. What of this?
Plus
Plus
8.
+8. -1 plus 8 will give you what?
+7.
7
+7. Here, what do we have? We have +2 here.
plus 2
And this one we have 0,
Plus.
right?
Yes, sir.
Is that not so?
is
Yes, sir.
No.
Yes, sir.
The
No.
overall ion that we have at the reactant side is +7, right? This one, the overall is +2, right? Who can tell me which side are we adding electron to?
Plus 2
+7. Huh?
We are adding it to +7
plus 7
now. How many electrons are we going to add to +7 to make it the same as this?
5.
minus 5
5. That shows that in this case, we add 5 electrons to this. When you check everything, you see that it has balance, right?
Yes, sir.
Are we together? Yeah, let's put it down. Let's put it down, please.
That H2O.
Yes,
Are you not going to use that 4 instead of that H2O for the
because we
electron?
did not have any ion here. If we have ion here, either plus or minus, that's when we can have the numbers of ion. But so far here, it is 0. Nothing is there. 4 times 0 is equal to 0. Are we together?
Okay. Yes, sir.
Please, are we done with it, please?
Yes, sir.
Are we done?
Yes, sir.
Yes, sir.
Okay. Now, the next step is that multiply by inverse. What do I said? Multiply by what? By inverse. So, what do we mean by multiply by inverse? You want the ion in equation 1 and equation 2 to be the same. Are we together? The ion in
Yes, sir.
equation, the electron in equation 1 and equation 2, we want it to be the same. Here we have 5. Here we have 2. Are we together? What we can now do in this case is that we multiply by inverse. You know, we have 5 electrons here. We multiply all this equation by 5. Why we have 2 electrons here, we multiply all this equation by what? By what?
2.
By
2.
2. That's what we mean by multiply by inverse. Are we together? So if we are to multiply equation 1 by 5, how will it be? You know, 5 times SO4 will be 5. SO2, sorry. right? 5 times 2H2O, it will be 10. Is that not so?
Yes, sir.
We are going to have 10 H2O. Five times 4 plus, it will be 5 plus, right?
Yes, sir.
So 5 times 4H plus, what will it be?
20H plus.
You have 20.
Is, cla- is class already finished?
I think it's the network.
Okay. Time have already gone now. So, Jazakumullah khairan.
Hello,
Well,
very
yeah.
sorry for the connection, please. Are we together?
Yes, sir.
Yes, sir.
So this one will give us 10. 10 what? 10 electrons. So we multiply equation 1. We multiply equation 1 by 5. Equation 1 by what? By 5.
By 1. 5.
Equation 2 you multiply by what?
Question by
By 2.
By 2. 2.
So if you have to multiply equation 2 by 2, what will it be? 2 times mn over 2 minus
2MnO4
Many
half 2 2 times 8.
is 10.
16.
So we have 5 there before. 5 times 2, that's 10.
10 E minus.
This one becomes 2. While the other one will become what?
10.
We have 8. That shows that we balance it with electron. Are we together?
Yes, sir.
No.
Yes, sir.
That's so the next step is that all reactants in both equations should be added together, while the product in that equation, the same equation, should be what? Should be added together. Are we following?
Yes, sir.
Yes, sir.
Yeah. We have the reactants of 5SO2 plus 10H2O. So we have 5SO2 plus 10H2O. That's the reactants of the equation 1, right? What's the reactant of the equation 2? This is the reactant. We have plus 2 MnO4 minus plus what again?
Plus 16H plus.
Plus 16H plus
Plus 10E minus.
plus 10 minus. We've added everything together. So which gives which gives 5SO4 2 minus 5SO4 2 minus. Are we getting it, please?
Yes, plus 8 plus 20H plus.
20H plus
Plus 10E minus.
plus 10E minus plus
Plus 2Mn2 plus.
Mn2 plus
8H2.
8H2O. So now we now need to collect the like times. Those that are the same, we remove them from each other. Now we have 10H2O here, right? And we have 8H2O here. When plus 8 H2O comes here, this one will become 2, right?
Yes,
So
sir.
this will be cancelled and this will remain 2. Are we together?
H2. Yes, sir.
Yes.
Do you still have anything that are the same?
10E minus.
10E minus, we cancel 10E minus here. Right?
Yes, sir.
What else again? We have 8
Nothing.
plus.
H plus
We have 16
HH.
here.
Okay.
We have 20 here.
20.
16 we cancelled and we have this one remain what?
4H.
Remain 4.
Anything to cancel again.
Nothing.
Nothing.
So our answer will now be 5 SO2.
SO2 minus.
SO2 only here. It's not SO2.
Okay.
2 H2O plus what?
Plus
Plus 2
2
NO.
MnO4
4
Minus.
minus
is 5
SO2 minus.
SO4 2 minus plus
4H plus
4H plus what else again?
plus 2mn plus 4. 2mn plus 2.
Is that okay?
Yes, sir.
Yes, sir.
So I think that's the equation has been balanced. Let's check if the equation has been balanced. How many sulfur do we have here? 5.
5.
Sulfur here, 5.
5.
Let's check the total numbers of oxygen. 5 times 2, we have 10 here.
10.
2 times 2 here, Abi.
Oh,
Yes,
10
sir.
plus 2, 12, right?
sir.
We have 2 oxygen here.
Yes, sir.
We have 10 here. We also have how many oxygen here?
You have 8.
8.
8 plus 2 plus 10.
20.
20.
20.
Also that here we have 20 oxygen in this equation, right?
Yes, sir.
So,
Let's check the product one. 5
Same
times
thing,
4.
sir.
20.
That's
20.
20. Let's check for hydrogen. Hydrogen that we have here is what?
4.
4.
4. How many hydrogen do we have here as well?
4.
Mn that we have here is how many?
2.
We have Mn here 2 as well.
2.
Yes.
That's why it has balanced.
Equation.
The equation is balanced. So you check if it is balanced ionically. There is nothing here, 0. Here also 0. But here, what do we have here? What's the ion here?
-1. Okay.
You have 2 in front, oh, don't forget.
Okay. -2.
Minus 2. Are we together?
Yes, sir.
Here, at the product side, 5 times 2,
-10.
minus 10 here. We have 4 here, Abi, plus 4.
Yes, plus 4. Plus
2 here, that's
Plus
2
2.
times 2,
4.
4
Plus
plus 4.
Plus 4.
plus 4.
Minus 10 plus 4 plus 4. What do we get?
-2.
Minus 2, the same thing. One of 2 are the product side, and minus 2 are the reaction side. That shows that the equation is balanced. So this is where we are going as well. So we need to go through it again and we understand it perfectly. Is that okay?
Yes, sir.
Any question? Time has gone already.
Jazakumullahu khairan.
Amen. Auntie. Amen. So do you need to write it or
Jazakumullahu khairan, sir.
I don't like it.
we've written it already? Abi?
Yes, sir.
Yes, sir.
Okay, let's call it a day. Thank you very much. So, very sorry, the pen is not writing, so I don't know what's wrong with the pen. So, for in our next class, maybe we'll have done that. All right, take care of yourself.
Yes, sir. Thank you, sir.
Thank you, sir.
Thank you.